Welcome everyone to the start of our journey into the world of statistical testing. Today we're tackling the t-test. Don't worry if it sounds intimidating. We'll break it down step by step. Think of this as the beginning of an exciting adventure, not just another statistics lesson. So, what exactly is a t-test? Essentially, it's a way to test hypotheses about the mean of a population when you don't know the population's standard deviation. Imagine you want to know if the average height of students at state university is different from a certain value. You take a sample of students and measure their heights. A t-test helps you determine if the average height of your sample is significantly different from that hypothesized value, taking into account the variability in your sample. The T in t-test comes from the pseudonym students, used by William Sealy Gosset, who developed the test back in 1908. He wanted to keep his employer Guinness Brewery from knowing about his statistical work. The name might be a little obscure, but the test itself is incredibly useful. The main goal of a t-test is beautifully simple: to compare two groups and see if they're essentially the same or statistically different. That's it. Now, when we say groups in statistics, we usually mean samples. But remember, there's also the idea of a population, which is the entire set you're interested in. The t-test helps you make inferences about the population based on the samples you've collected. Let's talk about populations and samples. A population is the entire group you want to study, like all college students in the United States. A sample is a smaller, manageable subset of that population that you actually collect data from, like a group of 100 students from various universities across the US. Because it is often impractical or impossible to collect data from an entire population, we use samples to make inferences about the larger group. The t-test helps us bridge that gap, allowing us to draw conclusions about the population based on the sample data. So, how does a t-test actually compare two groups? It checks if the means or averages of the two groups are statistically different. Imagine we're comparing the averages test scores of two different classes. If the t-test shows a significant difference, it suggests that the difference in averages scores isn't just due to random chance, but that there's a real difference between the classes. We need to evaluate the probability that the difference we see is simply due to random sampling variation. Here's a practical example. Let's say you suspect that students at Harvard University have higher SAT scores than students at Yale University. Are the SAT scores statistically different? We can use a t-test to find out. Suppose we collect data and find that the average SAT score for Harvard students in our sample is 1480, while the average SAT score for Yale students is 1450. At first glance, it looks like Harvard students scored higher, but this difference alone doesn't prove anything. A difference of 30 points may not be significant or real in the statistical sense. The real question the t-test helps us answer is, what's the probability that we see a difference of 30 points or more between the average SAT scores of Harvard and Yale students if in reality there's no difference between the two groups? In other words, what's the chance that the difference we see is just due to random variation in our samples? If that probability is low enough, typically below 5%, we reject the hypothesis that there is no difference between the population means.